Hello and welcome, friends. So, about a year ago, I made this step-by-step tutorials with Nexus vPC just to show how easy it is to make, what's the benefit, and talked about few tips along the way. Since then, several of my friends on YouTube requested to make an updated video showing how the failure situation works. We already know they're redundant pair, but what if the redundancy break? What if peer link goes out in a production? What happens if the Keepalive goes out in a production VPC domain? So that's why I'm back to make a short video to let you know and to show you what exactly happens in those scenarios. So stay tuned. Just a short overview. I have core 1 and core 2 in a VPC domain 10. I'm using directly connected management 0 port as my keep alive, and ETH1 slash 1 and 1 slash 2 are bundled in a port channel. I call it port channel 1, could be anything. Um, and that's my peer link. Now, management 0 ports or the keep alive routed ports where core 1 just sends heartbeat packets, ping packet, UDP ping packets to your core 2, and core 2 does the same thing to core 1. This is just a heartbeat, nothing else. Where your peer link is where control plane sync happened between core 1 and core 2. So there's type 1 and type 2 configurations that has to match, keep alive has to be there, and the peer link. Those are the few requirements to build your VPC domain. Now let's get to the detail of our failure scenarios. So pretty complex, and I tried my best to show you guys on this lab what happens if keep alive link goes out while peer link is active. But within the same scenario, what happens if your active primary member goes down versus what happens to your secondary member goes down? And then on a reverse scenario, your peer link goes out with keep alive active. What happened during that stage? Your primary VPC peer goes out, and then what happens if secondary goes out? So mix and match several scenarios. I've tried my best, so let's see what happens. So for my new viewers, core 1 will have VLAN 2 SVI with the IP dot 2. Core 2 will have VLAN 2 with dot 3, and HA address would be dot 1. And here my access layer switch will have dot 10, and this Windows PC would be dot 15. So access layer has port channel 1 redundant links to core 1 and core 2, and based on this scenario we will see what happens. Um, so I will be running a continuous ping from my Windows PC to this dot 1 address, and at each step what happens to that ping. That would be a good way to validate each scenarios. So let's get started. Show VPC. As we can see, my keep alive is good, peer link is good, and they have formed adjacency to VPC domain ID. Core 1 is my primary. I can see that port channel 1 is up, and for VPC status, we have port channel 10 to downstream access layer switch. That's core 1's perspective. Let's take a look core 2's perspective. So VPC. Again, peer adjacency form, Keepalive is good. It is a secondary member of the VPC domain 10, and we do have successful on creating a VPC port channel to downstream switch. So the configuration for that is port channel 10. The VPC 10, that makes it access layer switch to use redundant link to two different physical layer 3 box, but still be able to use both links. And on in respect of my access layer switch, let's take a look. Here you can see both ETH1 pointing to core 1, ETH1/2 pointing to core 2 are in bundled, and it is doing switching and it's up. Show IP interface BRI. This is 2.10, and let's get to my handy dandy. Here I'm already running a ping though to 192.168.2.1. That particular IP is currently hosting on core 1. Show HSRP BRI. Tells you that VLAN 2, my active address. This is an active HSRP active device. Standby is 2.3, which is my core 2, and 2.1 is the group address. So um, now let's take a look at what happens if my Keepalive goes out. Alright, so failure scenario 1A. Core 1, primary member, core 2 secondary, we lose Keepalive link. You see that Keepalive is down. We cannot reach core 1 cannot reach core 2 using ping packets, and but it retained the role. Let's take a look core 2. Again, we still have the adjacency, but we lost Keepalive. It still hosts the secondary role. No role change has happened so far. What happened to my redundant link from my access layer switch? So still, it continued to work. Both the links are up, bundled. It's telling me that we lost Keepalive, but both the member retained their role. vPC domain continue to work for downstream dual home devices, and it will also work for single home devices as well. Let's put a twist to it. What happened my primary node goes down during the situation? Let's take a look what happens. Keep Alive is gone and the primary node restarts or it fails. Let's take a look. I will speed this up so you don't have to watch this reboot. Now, the ping failure I can explain. Between core 1 and core 2, the peer link has failed, but the core 2 hasn't detected it. So in order to stop inconsistency, a spanning tree has blocked the downstream link from core 2 to access layer. In production, that detection of peer link failure would be immediate, so you will not have this STP blocking. This is simply the virtual environment where the link failure detection takes longer. So pings came back, core 2 detected my peer link is down, and it unblocked the downstream switch. So from my downstream access layer switch perspective, um, I have 1/1 suspended because it is down, and until it comes back and it syncs all the control plane data, that will not come back in bundle. But the question is, will Core 1 come back and join the vPC domain 10? It will not, but I will show you and explain why. By the way, one vital point on Core 2's perspective that it has taken up the primary role. So recap, Keep Alive is down and we lost primary member. So it took over the primary role. But Core 1 is up. Will Core 1 join? Okay, vPC role non-established. So as I mentioned, the beginning part of this video, keep alive is needed. Number one, needed parameter to build the vPC. As it is down, it will not come back. So let's re-enable it. As soon as I re-enable, both core 1 and core 2 will start passing heartbeat ping successfully, and it will take a few seconds for the timer, the delay restore timer, SVI timer will go off, and core 1 will join as a secondary. All right, it detected peer is alive. Peer is alive. Core 2 primary link is still down. Right. It took about a few seconds. Um, I see my peer adjacency form. Right now, this SVI timer has gone off and delay restore status timer is going off. During this time, my port channel from downstream will still have the primary member suspended. As soon as that timer finishes, it will bring up that primary link from access layer. It's almost there, right? That is gone. And this member should be up, all right? As you can see, access layer has both the links are up now. And we detected the peer link came up. Sorry, the Keepalive came up. Peer link was already good. And they're back into production with redundancy for our network. Role change has happened during that Keepalive and primary member failure. All right, so scenario 1C, core 1 primary, core 2 secondary, lost Keepalive, and now we lost secondary. So from the previous scenario 1B, we have core 2 now acting primary. Core 1 is secondary. So once we restart secondary, which is core B, the role should fail over. Um, so let's take a look. So with the Keep Alive failure, one thing for sure, your network will continue to work with both the nodes or if one of those fails. Bad thing is that if a peer restarts, it will come back but not join the vPC domain. Peer link, or sorry, my Keep Alive is still down. So for Core 2's perspective, let's fix that Keep Alive. It will detect it immediately. It's a routed port. And then it will take a couple of seconds for my lab environment to detect the peer link up, and it will sync the configuration, the control plane data from the primary member, and then it will come back. Link to core 2 is still down. Ping continue to go on. The network is still fine. We're waiting for this core 2 to detect the peer link that is active now. Keepalive is active, so just take a few more seconds. All right, looks like my peer adjacency is formed. Um, let's see this side. There is this delay restore status going off right now, and my port channel should still be suspended. As soon as this clears out, which is now, we should have a redundant link from access layer's perspective towards the core. So there you have it, guys. Moving on to the next section, which is failure with the peer link. So stay tuned. All right, so I realize this is not turning out to be a small video, so I will kind of zip through the next scenarios. So core 1 primary, core 2 secondary, and we lose the peer link while keep alive is still active. And then we'll simulate primary and secondary failure. So let's get started. Redundant links are good. Pings are going okay. Let's turn off the peer link. All right, so at this point, it's going to take a few seconds for the link disconnection to be detected by my virtual environment. I'm going to pause it pretty much about a minute because LACP heartbeats goes about um, 10, I think 60 seconds, so about a minute. And by the way, peer keep alive will still continue to work. All right, I see my peer link is down. Core 1 still remain primary. Core 2 still continue to be the secondary member. Uh, Keep alive still active. What happens to my ping? Ping continues. And let's take a look at the port channel. So now you know secondary being the link to the secondary core is suspended. Um, because if this access layer switch were to split the data in both the link and partial data reach secondary node core 2, it doesn't have the pure link to send it back to core 1. So it is shutting it down, the downstream link. And all this is happening because we still have Keep Alive. Keep Alive letting each other know that, hey, we are still on, we just lost the peer link. So this is um, within Nexus environment, if you lose peer link, your secondary member would suspend all the links to downstream access layer switch, may that be a server, any dual home device will lose it or will get suspended on the link to the secondary. Now, a single home device or orphan ports right now will have no way to be reached from the active member. If there is a single home device on core 2, the active traffic which passes through core 1 doesn't have a way to get to it because the peer link is down. Hope that makes sense. So moving on, and we will um, at this time simulate our um, failure scenario 2B, which is restarting the active primary member. Now this is the only member the data is traveling from your network. Your access layer has this one active link. Now what if that goes down? Then of course your network will fail. Um, and that's what I want to simulate. And later on, at this point, you know if your secondary node restarts, no, not much difference because the links to that secondary node has already been suspended. So if that restarts, your network will not face with catastrophe. It will continue to work, but primary goes down. Your secondary node will no longer assume the primary role because beforehand it knew I did not have my I did not have my peer link, only I have my heartbeat detection, my keep alive. So if primary member goes out, secondary will not assume the role and your network will pretty much come to a halt. So let's reboot primary member and take a look at it. So as you can see, this link is still active. It is about to go down and you will soon see that the ping will start failing. So network is totally down and will stay down until you fix this issue. Your member one needs to be up and your peer link needs to be fixed and it will join the vPC domain and will bring the connection up from your access layer or any dual home downstream devices. And until then your network is down. All right, so it will just want to show you this will not join the VPC domain. Peer link is down. It detect the keep alive is active. So that's your number one requirement. So let's fix the peer link and these two cores will detect the second requirement is done, then it will perform a consistency check. If there is no configuration type 1 or type 2 inconsistency, it will then go on about these two timers will go off, and then your core 1 will continue as primary while your core uh, 2 will continue to be secondary. So let's bring this link up. All right, it came faster than I thought this time. It detected the peer link is back on. Again, we got the delay restore SVI timers going on right now. And then we'll have the delay restore status for the whole VPC that will continue after that 30-second timer. We will see the core 2, which is the secondary, enable or take away the block from the downstream switch link, which is our ETH1/2, this one. So it will come back online. So, okay, timers are cleared. Ping continues to work. Let's take a look at the port channel, and both are up. So pretty simple. All right, both the links are up now from my access layer. Core 2 became secondary, of course, from adjacency. So production came back. Your Nexus VPC domain has now primary and a secondary, and there is your traffic start flowing. As I mentioned, at this point, if I restart with the peer link being down, if I restart my secondary node, it is not going to make any more difference because the link to downstream devices from secondary node is already suspended. Okay, friends, so this concludes the tutorial with Keepalive and peer link failure with VPC. Needless to say, your VPC Keepalive and peer links are as needed to create your VPC domain, but also needed to keep them operational. Also, to get the best benefit out of your Nexus environment, try your level best to make everything dual home, specifically your servers, your IDFs, like your access layer switches. That way you can get the best benefit out of your Nexus VPC domain. I appreciate your input with my Nexus VPC videos and requesting me to make this additional video. With my busy schedule, I try and I will continue to try to provide valuable content for all of us that are wanting to learn and continue their learning path. So keep up the good work, keep learning, and I'll see you soon with another video.